Let's do one more example. In this one, let's find the area underneath the curve, 3x squared plus 2x on the interval from 1 to 3. So, as before, we'll divide the interval into n equal parts. The width or base of the rectangles is going to be delta x. The formula for that is b minus a over n. Since my interval is from 1 to 3, a is 1 and b is 3. So b minus a is 2. And then I divide by n to get the width, delta x. The right endpoint of r sub I is the left endpoint plus delta x times I. The left endpoint a is 1. Delta x is 2 over n times I. That's my formula for x sub I. The height of r sub I, if I use the right endpoint approximation, is f of x sub I. I take x sub I and substitute it into f. So that's 3 times x sub I squared plus 2 times x sub I. So there's going to be a little bit more algebra going on here. For x sub I, I'm plugging in 1 plus 2 over n times I. So let's do some algebra to expand this out before we move to the next step. Foiling this binomial out, I'll have 1 plus 4 over n times I plus 4 over n squared I squared plus 2 times 1 plus 2 over n times I. And then I'll distribute the 3 over the trinomial and distribute the 2 over the binomial. So I have 3 plus 12 over ni plus 12 over n squared I squared, and distributing the 2 plus 4 over n times I. And finally, let's collect like terms. 3 and 2 is 5. 12 over ni plus 4 over ni is 16 over ni. And I still have the 12 over n squared I squared. And remember, that represents the height of the ith rectangle. So the area of r sub I is going to be the height times the base, or the height times the width. So that's f of x sub I times delta x. So 5 plus 16 over ni plus 12 over n squared I squared multiplied by 2 over n. I'll go ahead and expand that over here. That's equal to 10 over n plus 32 over n squared I plus 24 over n cubed I squared. And that represents the area of exactly one interval. So to get the area of exactly one rectangle. So to get the area of all n of the rectangles, I have to add them all together. So the area of all n rectangles is given by our Riemann sum. Sum I equals 1 to n f of x sub I times delta x. So that's the sum I equals 1 to n of that expression we derived. 10 over n plus 32 over n squared I plus 24 over n cubed I squared. So now's the step when I split this up and substitute in my summation formulas. So when I split this up, I'll have 10 over n times the sum I equals 1 to n of 1 plus 32 over n squared times the sum I equals 1 to n of I plus 24 over n cubed sum I equals 1 to n of I squared. Here I skipped a step that I put in the previous videos. Now, these three sums can be replaced by formulas 1, 2, 3 at the right to give me 10 over n times n plus 32 over n squared times n plus 1 over 2 plus 24 over n cubed times this bottom formula. N times n plus 1 times 2n plus 1 over 6. Simplifying a bit, the n's cancel here. Here I can cancel one of the n's from top and bottom, and I can also cancel a 2 from top and bottom. That leaves me with the 16 on top. Here at the end, the 6 goes into 24 4 times, and I can cancel one of the n's. So let's see what we have. 10 plus 16n plus 16 over n plus 4 times, I'm going to multiply this out, 2n squared plus 3n plus 1 all over n squared. As I mentioned before, it's not necessary to get a common denominator because our next step is going to be to take the limit of this as n goes to infinity. So last, I'm going to save a little bit of space here and just write the limit of this as n goes to infinity. So I take the limit as n goes to infinity of 10 plus 16n plus 16 over n plus, let me distribute this 4, 8n squared plus 12n plus 4 over n squared. The limit of a constant is just the constant, 10. This first fraction is balanced, so I take the ratio of leading coefficients, 16 over 1. This last fraction is also balanced, so once again, the ratio of leading coefficients, which is 8. And 10 plus 16 plus 8 is 34. And that's the area underneath the curve.